Welcome everyone. I am your favorite physics teacher, TS sir, a teacher by choice, not by chance. I welcome you all to another session on this topic, mistakes and misconceptions in physics. Today's question is, can acceleration be greater than F by m? All of us, we know Newton's law that acceleration equal to force by mass. So here, what I mean by the question is, let's say here is a body whose mass is 4 kg, and now let's say I am applying a force of 20 Newton here on the body at the topmost point. Its radius is 2 meter. So now what do you think will be the acceleration? As per Newton's law, we know that acceleration is equal to force by mass. So will the acceleration be force by mass 20 by 4, that is 5 meter per second square? Or will the acceleration be less than 5 meter per second square? Because in this question there is friction, so we may want to apply the concept that friction opposes motion. So we are trying to push the body in this direction. So what if friction acts in this direction? Then the net force becomes less than 20. So will the acceleration be less than 5 meter per second square? Or do you think the acceleration is more than 5 meter per second square? So now let me put the question in this way. Here force by mass is 20 by 4 equal to 5 meter per second square. So what is the acceleration in this situation? Will it be 5 meter per second square, that is F by m? Or will it be more than 5, that is more than F by m? Or will it be less than 5, that is less than F by m? That's the question. What do you think? Many times students think that the acceleration should be 5 F by m, 5 meter per second square. Or some students, they think that because friction opposes motion, so friction acts in this direction, so net force in that direction is less than 20, so the acceleration should be less than 5 meter per second square. But actually here the acceleration is more than 5 meter per second square. Let's see. So this is a question based on friction and rolling. So while solving this, we may require some previous understanding of rolling friction, how friction acts. So let's continue. So the concept to be applied here is, in this situation, the friction adjusts its value in such a way that the body can roll. Right? Yes, you heard me right. The friction adjusts its value in such a way that the body can roll. The body can roll mean, by that what we mean? The body can roll means it will have its ASUM in this direction, and it will have its alpha in this direction, and it rolls. And rolling means, the condition for rolling is the values of A and alpha are such that A equal to R alpha. So now friction in this question will be acting in this direction, and it will adjust its value, magnitude and direction in such a way that the body can roll. That means the A and alpha, the acceleration and alpha, they get related like this, right? So now some of you might be getting shock of your lives here. Why did I apply friction in this direction? So that's the concept. So we might be having our conceptions of how friction acts. So some of us may think that friction opposes motion. So because we have applied the force 20 Newton in this direction, so friction should oppose it. So friction should act in this direction. No, where it is written, that's not the concept. So the concept of friction is not that it opposes motion. The concept of friction is not that it is against the applied force. The concept of friction is that the friction adjusts its magnitude and direction in such a way that the body can roll. So here we will take friction as a variable, and we will assume that let the magnitude of friction be F and let its direction be in this direction. And then we will solve it, A equal to R alpha, and from here we will try to get the value of friction, the magnitude and the direction. Let's say after solving we are getting the value of friction as plus 5. That means friction 5 Newton will be acting in the given direction, in the assumed direction. Let's say after solving this we get F equal to minus 5. That means the friction acting is 5 Newton, not in the direction as we have assumed, but in the opposite direction. So that's what is the implication of this assumption. So let's continue. So here After we apply a force of 20 Newton, friction starts acting in this direction. So now what is the net acceleration of the body? It is total force 20 plus friction by mass, that is 4. Acha, what is alpha? The alpha will be tau by I. What is tau? What is torque about this axis, about center of mass? So here I am using torque about center of mass by moment of inertia about center of mass. So in combined translation and rotational motion, so the alpha of the body can be found by tau about center of mass by moment of inertia about center of mass. So what is torque about this point? It is 20 into R. 20 into R. So this force tries to rotate the body in this direction, minus friction into R. Friction is trying to rotate the body in this direction. So minus friction into R by moment of inertia. Here, the moment of inertia of a disc. Anyone knows the formula? It is half mr square. That is half into 4 into 2 square. How much is that? That is 8 kg meter square. So I am not writing the unit there because the space available is very less. Now, so the moment of inertia is 8, right? So let's keep some gap there. Okay, so this can be simplified as 20 minus F by 4. So if friction F acts in this direction, then this is the value of A and this is the value of alpha. Now friction gets adjusted so that A can be equal to R alpha. So let's put the value of A and alpha there. So here, how much is A? A is 20 plus F by 4, right? How much is R? It is 2. How much is alpha? This is alpha. 20 minus F by 4. So what do you get? So 4 and 4 gets cancelled out. We have 20 plus F equal to 40 minus 2F. So this comes out to be 3F equal to 20. So F equal to 20 by 3. So we are getting F equal to 20 by 3 plus 20 by 3. That means in this question, if you apply a force of 20 Newton, then friction starts acting how much? 20 by 3 Newton in the same direction as the direction in which you have applied the force, right? So now if this is the situation, after you apply force, if friction also starts acting in the same given direction, then tell me how much is the acceleration here. So then the value of acceleration is, it is 20 plus friction, that is 20 by 3 by 4. How much it is? It is 5 plus 5 by 3. How much that is? It is 20 by 3. How much that is? It is 6.67 meter per second square, right? So the acceleration of the body in this case will be 6.67. Has Newton's law become invalid? We have heard that force equal acceleration equal to force by mass. So force is 20, mass is 4. So why it is not 20 by 4? 5. Why it is not 20 by 4? That's 5. So here it's not 20 by 4 because when you are applying a force of 20 Newton, a friction also starts acting. So the acceleration becomes total force 20 plus 20 by 3 by 4. That is 6.67. So Newton's law has not become invalid. It's still we are calculating A equal to F by M only. But here that F net is not only the force which we have applied. Here F net is the force which we have applied plus the friction, right? So Newton's law is not invalid. But yes, here acceleration is not 20 by 4. The acceleration is more than 20 by 4. It is 6.67. Hope this satisfies you. Thank you so much.